Hello everyone, so in this particular video we are going to continue with our last video in the series or rather on the topic of convolutional 2D. Okay, so we had covered almost everything. So in this particular video we will be covering groups and we'll be talking a little bit about bias, but that is simple, and also we'll be covering this particular formula, which is I think is very important if you want to properly understand convolution. Okay, so let's start with groups. So what are groups? So if you come over here, if you look here, let me go here. It says number of blocked connections from input channels to output channels, default equal to 1. So not very helpful. And if you go over here, you can see groups control the connection between the inputs and outputs. In channels and out channels, both must be divided by groups. For example, this is. So let me first explain what that is, and what groups are, and why again I think it's not very it's not a revolutionary thing. So basically what happens whenever you are saying convolution, you need to do two things over here. At least you need to say how many in channels are there and how many out channels are there, right? So if you are someone who understands this, in channels is the number of channels that the convolution operation will get. Okay, and this is out channels is basically the number of channels that the convolution operation should produce. Okay, now what happens is, in general cases, like general cases where groups equal to 1, what happens is you basically have that many, let's say if this is 100, in channels is 100 and out channels is 200. What happens is you will have 200 different kernels. Okay, and each kernel will be responsible for each kernel will basically, let's say if it is a 3x3 kernel, and you had, let's say out of 200 kernels we have one kernel over here, and obviously since there are 100 in channels, so let's say, so this is the image, so then this is second channel over here, then this is to say a third channel over here, and dot, this is 100th channel. So each kernel will be placed over here on this side, it will be placed over here. So it will cover 3 in the height direction and 3 in the width direction, but the entire 100 in the depth dimension, right? If you understand convolution, you should understand this. And same thing for the second kernel. Even the second kernel will start over here, and then it will occupy 3 in the height and 3 in the width, but again 100 in total to say your depth, and so on and so forth for 200 kernels. What groups does is it says, we will not let me write it over here. Okay, what group says is, we will say in group that if, let's say, group equal to 2, what will happen is these 100 channels will be divided into two groups. So 100 divided by 2, that's 50. So earlier we had let's say 100 channels. We will continue to have 100 channels, but in this case we will have 50 in one group and 50 in other groups. So this is, let's say, group 1. Okay, dot 2, this is 50th. This is, let's say, group 1, G1, and then again you'll have group 2 over here. Okay, so this is group 2. Okay, so we'll have how many over here? Again dot 50 channels. Okay, 50 channels. So 50 channels over here and 50 channels over here. Now same thing will happen over here. Now so obviously groups, we had in channels that equal to 100, and so we divided divided that by 2, number of groups, we have 50. Same thing for the out channels. Out channels also, initially we had 200. How many groups? 2 groups, so that will become 100, which means here you will have 100 kernels, and all of these 100 kernels will be, again, in the first case the depth was 100, here the depth is 50. So all these 100 kernels will be responsible for doing, let's say this is 3x3, so it will be 3x3, but the depth this time will be 50. Okay, and same for here. So here also you'll have 100 kernels, and all kernels will be doing convolution in the depth of 50. Okay, so this is the idea basically. Okay, finally at the end again you will have the same thing. You will have 100 kernels from here, and then 100 kernels from here. Again it will become 200 only, so nothing changes as such. But again, this is one of the reasons why I said that this is nothing revolutionary. Okay, but again I had to explain So I have explained it. Okay, so nothing revolutionary in this. Okay, let's go back. So what happens now? One general case is over here. I think they have explained it in the over here. When groups is equals to in channels and out channels equal to k into in channels, where k is a positive integer, this operation is also known as a depthwise convolution. Okay, so very simple. Again, let's go over here. Let's say you have 100 channels. Okay, in channels was 100, just as the above. Okay, and out channels were, let's say 200. Okay, so what it says is, let's go back. It says when groups equal to in channels and out is equals to k into in channels. Okay, so let's say groups equal to 100, groups equal to 100, which means groups equal to num in channels. That is correct, because in channels is 100 and groups is also 100. And is out channels integer multiplication of out in channels? Yes, 2 into 100, that is 2 into in channels. So you can see over here it is 2 into in channels, k into in channels. What is that? When this happens, you can't we say that in each kernel will only convolve with one particular in channel, right? Because we had, for how many group how many what to say, what will be the depth? In the second case, when groups were equal to 2, we divided 100 by 2. But now we are saying that groups equal to 100, so we have to divide 100 by 100 equal to 1, which means one kernel will work only with, or to say your one kernel will work with one channel, but produce how many? 200 by 100, that is 2. So there will be, for every one for every channel there will be two kernels, and every kernel will be, as I said, responsible for one channel. So I hope you understood that. Okay, so this when this condition is satisfied, we say depth wise, what is that called? Depthwise convolution. That is called depthwise convolution. Again, nothing, as I said, nothing revolutionary. Why? Because I haven't seen it being used anywhere, in a grandiose way or something like that. Okay, so that was one idea. Let's talk about a bias a little bit. So what is bias? In general neural network, we know what is bias, but if you have seen the first video, I'll remind you that if you have a kernel of size 3 by 3, then there are 9 weights. That is 9 weights. Why? 3 into 3 equal to 9. But what is the bias? Only one bias, right? So when you say bias equal to false, these 9 weights will continue to exist. The bias is gone. We will not take bias. Again, it will reduce the number of parameters, but again, a generalization power might reduce a little bit. So that is there. And let's go back to the most important thing of this particular video, which is this particular formula. So this particular formula is simply, what this means I'll explain to you. So this is basically you understanding what is going to be, okay, what is going to be the size of output if these parameters, if these, I'll show what these, if these parameters are there, are there. Okay, basically what? So let's say our in channels is 100. Okay, so we'll have to assume all these things. So let's say in channels equal to 100, right? After that, padding I have already explained. Let's say padding equal to 2. Okay, padding equal to, now one thing I want to explain is, this is height and this is width. Okay, but this formula is almost the same. You can see only the index differs, but the formula remains the same, which means it doesn't matter whether you use it in the height or width dimension, it is going to be the same. Okay, so so let's say padding equal to 2. Let's say dilation, I have already explained dilation equal to 1. Let's say dilation equal to 1. And also let's say kernel size equal to 3, and let's say kernel size equal to 3. And do we need anything else? Yes, stride is equal to 1. So let's say your images, as I said, let's say your image dimension is, let's say batch is 16. Obviously it's in 100 in channels is already there, so I cannot change that. In channels is already 100. And let's say your image is 224 comma 224. This is the height and this is the width. So if this is the case, what is going to be the output? So this is input image. Okay, what is going to be the output image, or whatever feature map, whatever you want to say, if we use convolution with these parameters? Okay, so how do you know what is that? We use this particular formula, and I'll show you in the code as well. Okay, so let's go and look into the code. So in our case, let's say our what to say, your input here is 20 is the batch size, 16 is the number of channels, 50 is the width of the height of the image, and 100 is the width of the image. So let's say, so 16 over here is your in channels, because you can see 16 is over here, 33 is your out channels. Okay, 3 is your, I think this is kernel size. So 3 is the, when you say 3 kernel size, is basically 3 cross 5 means you know how to write 3 cross 5, right? So you will have 3 rows and 5 columns, something like this. So 5 columns, 1 2 3 and 4, and 3 rows, so two rows over here, 2 lines over here. Okay, so this is 3 cross 5. So this is the size of the kernel over here. Okay, stride again 2 comma 1. So in the x direction the stride is 2, and the y direction the stride is 1. Okay, I have already explained all these things. Okay, once that is done, padding again, padding to 4 comma 2. So in the upside you have 1 2 3 4 whatever, so you have like a 4 over here. So basically this is one row. Okay, and then there will be more rows over here. There will be, you know, one row over here also, then 3, and then 4 rows over here. And if you go a little down again, you'll have 4 rows over here also. Then here will be 2 rows over here, 1 2, and here will be 2 rows over here, 1 2. Okay, so this is how padding will be there. And you have dilation. I've already explained, I won't be going into that. So if this is the case, okay, and this is the input, so how you'll then, if you do the convolution over here, what is the shape of the output? The batch size won't change. Obviously the in channels have become out channels. So out channels here was 33, now you have out channels as 33, and your height has from 50 reduced to 26, and your width has remained the same. Now how did we figure out that, how even before doing the convolution 26 is going to be the number? So the way you do it is use this particular formula. So in this particular formula you can see first is h in. What is the in? I have actually manually done it over here. So h in, that is the input height. So what is the input height? Initially it was 50, you can see over here, so we have written 50. Then you have 2 into padding of 0. So 2 into padding of 0, so it is 2, and padding is from here, so padding of 0 is this, so this is padding. Then what you have, dilation into kernel size minus 1. So you have dilation is 3 in the start, if you remember over here, 3, and then kernel size minus 1. So this is kernel size of x, so that's kernel size of x, and then minus 1. After that you have this again minus 1 divided by stride of 0, and then add 1 to it. So then you have minus 1 over here, then the stride of 0 is 1, as you can see the stride is over here, 0 is 1, and then plus 1 to it. Okay, so if you run that you get 26.5. Okay, and as you can see over here, we will take the lower. Okay, you can see over here, this is the lower part, so we will do a lower of that. So 26.0 26.5 will become 26, and same thing for this one also, height also. So I hope you and then again there is variables, weights and bias. Again, if you have bias equal to false, this value won't be there, and it has been sampled from a uniform distribution of from minus k to k, where k is this entire thing. All these things don't really have much of a bearing when we are doing training and stuff. So I hope you like the video. If you like the video, please like and subscribe. Thank you very much, and bye.